Good morning, children. This is Mr. Aftab here, and today we will start with the discussion of the very first chapter in physics for class 8. The topic is matter. Now, starting with the definition, matter is something which occupies a space and has mass and can be perceived by our senses. Examples, we are familiar with the examples, a large number of examples of matter. Anything which we can sense in our surrounding, like for example, air, water, piece of iron, oil, sugar, salt, anything, or rather, we can say matter means all the living and non living things of the universe. That together, these all are examples of matter, different examples of matter. Now, matter is composed of tiny particles which are called molecules. A molecule can exist free in nature and it has all the properties of that substance. Means a molecule, it represents that particular substance of which that molecule is a part. So a molecule of a substance will be exhibiting all the properties of that substance. But the most important aspect, or you can say the most important property of a molecule, is its property of existing freely. And this is also the most important difference which a molecule exhibits as compared to an atom, because an atom may or may not have an independent existence, but molecule, it always exists independently. Now, since we have started the discussion of molecules, so let us discuss some more characteristics of molecules. First of all, molecules are very, very small in size. Very small in size. Now, a molecule is of size nearly 10 raised to the power minus 10 meter. It is too small, it cannot be seen even with the help of a simple microscope. Now you can imagine how small a molecule is. Secondly, they have spaces between them. Now, the spacing between the molecules of matter is called the intermolecular space. The space between two molecules is known as intermolecular space. And it is this intermolecular space which is a very, very important deciding factor in deciding that to which state a particular form of matter belongs. Now, that we will definitely discuss very soon. I'm just giving an outline of what or how this intermolecular space is also a deciding factor in deciding that whether a particular substance will belong to the category of being a solid or a liquid or a gas. So, the intermolecular space will be the least in solids. More than solids, the liquids exhibit more intermolecular spaces as compared to solids, and the intermolecular spaces is the maximum in gases out of all the three states of matter, that is solid, liquid and gases. In other words, molecules are more closely packed and lesser less closely packed in liquids, and still less in gases. Third property, third characteristic, they are in constant motion. Now, what does it mean? The molecules of matter, they are not at rest, but they are constantly in motion. In solids, the molecules vibrate about their main position, but because they are bonded together with a very, very strong force of attraction, so they cannot leave their positions. In liquids, the molecules are free to move well, but they cannot leave the volume of the liquid. Rather, they can just move throughout the volume of the liquid, or you can say within the boundary of the liquid. And in gases, the case is just the reverse. The molecules can move in a random manner everywhere in the entire space which is available for that molecule to vibrate or to move. Now, the fourth and the last characteristic of molecule, they attract each other. Molecules exert a force of attraction. This force of attraction is called intermolecular force, and the intermolecular force is neither due to their masses, that is gravitational force, nor due to their charges, electrostatic force, but this force is a very strong attractive force. It is effective between the molecules only up to a separation of 10 raised to the power 9, 10 raised to the power minus 9 meter. And as the separation between the molecule becomes more than 10 raised to the power minus 9 meter, this force vanishes. Now, this force of attraction which is there between the molecules of a substance, this force of attraction is also further divided into two categories. If the molecules are identical, means the molecules between which the two molecules between which this force of attraction is existing, both the molecules are of the same substance, that is, they are identical, then in that case the force of attraction between the molecules of same substance or similar molecules, it is known as force of cohesion. And if the molecules are different, like suppose there is a force of attraction between two molecules which are of two different substances, means the molecules are not identical in this case, then in that case, when the molecules are not identical, in that case the force of attraction will exist, but in that case the force of attraction between dissimilar molecules will be called as force of adhesion. I repeat, force of adhesion. Now, for example, these are the simple definitions for force of cohesion and force of adhesion. Force of cohesion, the intermolecular force of attraction between the molecules of same substance is called force of cohesion, while force of adhesion, the intermolecular force of attraction between the molecules of two different substances is called force of adhesion. Now, coming on to the next property is, now we are going to discuss about the states of matter. Now basically there are three states of matter: solids, liquids, and gases. Now the question arises that what are the factors which decide the state of a substance? Though a few points we have already discussed, but still now we are going to discuss them in a bit detail. Factors which decide the state of a substance are as follows. First of all, intermolecular space. as we discussed earlier. We know that in solids, the intermolecular space is the least. But what is the difference between liquid and gases? In liquids, the intermolecular space is less as compared to that in the gases. So when we compare solids, liquids, and gases, we find that the intermolecular space is least in solids, more than solids in liquids, and maximum intermolecular spaces are present in gases. Now, the next factor which decides the state of a substance is the force of attraction between the molecules. Now, force of attraction between the molecules is a very, very important deciding factor, because it is actually the force of attraction which is also in turn deciding the intermolecular space between the molecules of that matter. See, the higher is the force of attraction, the closer will be the molecules, and closer will be the molecules, lesser will be the intermolecular space. And the third factor which decides the state of substance is the kinetic energy of the molecules, which is due to their motion. Now see, the word kinetic has been derived from the word kinesis, which means in motion. So from where does this concept of kinetic energy comes when we are deciding or when we are discussing about the arrangement of molecules in a substance? It is actually the amount of heat which decides the kinetic energy of the molecules. When we supply heat energy from outside to a state of matter, it is the molecules which absorb that heat energy. After absorbing that heat energy, they start vibrating with a greater amplitude, and they easily overcome the force of attraction which is present between the two molecules of a state of matter. And after overcoming the force of attraction, the intermolecular spaces increase, and this often leads to a change of state that definitely we will discuss very shortly in our discussion. Now, first of all, before proceeding to the next topic, let's quickly discuss the basic structure of a solid, liquid, and gas, and what is the factor which is deciding that to which particular state a substance belongs. Like for example, in solids, if we talk about solids, in solids the intermolecular force is very strong, and conversely the kinetic energy is very less or very small. So the intermolecular space is reduced, and hence in that case matter exists as a solid. Next state of matter, that is liquid. When intermolecular force between the constituent molecule is not much strong and the kinetic energy is sufficient for the molecules to move to and fro, and the intermolecular space is increased as compared to that in solids, then the matter exists as a liquid. And finally, in gases, what happens? When the intermolecular force is negligible, as a result, kinetic energy is very high. So the molecules are free to move throughout the entire volume available to them, then the matter exists as gases. Now, the basic differences. Now, the basic differences between solids, liquids, and gases. Let us discuss them one by one. The first difference between solid, liquid, and gases is in solids, they have definite shape and a definite volume. Liquids, they have definite volume but no definite shape. While in gases, neither gases have definite volume nor a definite shape. Now, let's elaborate this difference or this point. As I said, solids have definite shape and a definite volume. Why it is so? The reason is in solids, the molecules are very closely, very tightly packed with negligible intermolecular spaces. But the force of attraction is extremely high. Now, as a result, the molecules are not free to move or to leave their position, and hence the shape of the solid remains intact or fixed and definite. While in liquids, as compared to solids, in liquids, the intermolecular forces of attraction is weak, and hence there is a little intermolecular space and the molecules are slightly free to move and leave their position. So as a result, they have a definite volume, but the shape is not definite. So what happens, how can we define the shape of a liquid? Simply we can say the liquid just takes the shape of the container in which it is kept. The moment we change the container, volume will remain same, but shape will definitely change. And in gases, gases neither have a definite volume nor a definite shape because the intermolecular forces of attraction are negligible and very large intermolecular spaces are present, due to which the molecules are completely entirely free to move about in the entire volume available to them. Second difference between solid, liquids, and gases. The molecules in solids can only vibrate to and fro about their mean position. Now, why it happens just now we discussed, because of very, very strong forces of attraction. The molecules are not allowed, not free to move or leave their position. While in liquids, the molecules can move within the boundary of the liquid, while in gases, the molecules in a gas can move freely in the available space, because in gases, as I said, intermolecular forces of attraction are negligible. Third difference, the molecules in solids remain fixed at their position, as I said, due to very strong forces of attraction. In liquids, the molecules are not fixed at their position, while in gases, the molecules are not fixed at their position. Again, fourth difference, in solids, the intermolecular forces are very, very strong. In liquids, the intermolecular forces are less strong as compared to solids, but yes, stronger as compared to gases. While in gases, the intermolecular forces are very weak, okay, because of which the molecules are completely free to leave their position. And the last very important difference, solids cannot flow. Reason we have already discussed, because forces of attraction are very high, molecules are not allowed to leave their position, so the shape is also fixed, volume is also fixed in case of solids. In liquids, liquids can flow because forces are weaker as compared to solids, and in gases, a gas can flow as well because there are almost very large intermolecular spaces, almost negligible force of attraction is present. So these are the basic and most important differences between the three states which we have to study in this chapter, that is solid, liquids and gases. Now in the next lectures we will, in the upcoming lectures, we will definitely discuss about the changes of the states of matter. Thank you.